Another reason tropical storms are likely to rapidly intensify away from shores is because they move away from rivers and hence sources of natural carbonation in the oceans from what flows down rivers, the life, the detritus, the nutrients and so forth that flow down rivers, and then start life cycles and increase the carbon load in the oceans, and hence the conductivity increasing source when a surface low crosses the ocean. The other predictive thing about looking at the storm electrically is that you can start to look at space weather. Now, not space weather in terms of heat and a source of driving the thermodynamics of the tropical storm, but rather a source of organization that comes from the fact that there's more charges in the ionosphere to organize above a storm, and hence to statically attract the ionosphere is easier. It causes the subsistence better over the storm and organizes it, prevents shear from happening. And this year was a particularly special year to look at space weather because we had a number of spotless days that corresponded to a 100-year low going back to 1912 to 1914, when there was also these strings of spotless days. And sure enough, 1914 was a year where only one tropical storm was observed in the Atlantic. It was very quiet that year. And based on that, I was able to make a prediction before the tropical storm season began, that because space weather conditions were not conducive to having a lot of ozone, a lot of ions in the upper atmosphere, in the ionosphere, that the tropical storm season would be very quiet. And indeed it was, until later in the season, during peak lightning, which global peak lightning is around August 15. Tropical peak lightning, there's a double peak, one in the spring and another on October 15th. And between those two peaks is when the forcing from added CO2 from fossil fuels is going to be expressed. And this year was no different. In the Arctic, you had 2 standard deviations. We've had 3 years in a row with 2 standard deviations or more of melting during the specific time of peak lightning. And a conductivity variable like CO2 can only be expressed when you have currents, and currents occur during peak lightning. And there are now studies that indicate that the tropical storm numbers correlate strongly to when the melting anomalies are occurring in the Arctic ice sheet, and the tropical storms again are very sensitive to space weather. This year, because of the number of spotless days, the earlier part of peak lightning around August 15, you didn't see the 2 standard deviation. It occurred towards the end as we moved into the sunspot cycle. There was a few sunspots, and with them came very large storms also associated with a dam called El Cajon in western Mexico, and all these are electrical conditions. The other interesting electrical condition is the QBO, which is another oscillation index in the tropics. It's an upper level wind at 30 to 50 millibars. Again, having very closely to do with shear and how shear is impacted electrically during the shift that this every couple of years this index moves back and forth. It is again correlated strongly with tropical storms, and it's correlated when the index goes to when the wind blows one way. In this season, the time that it's correlated didn't occur until later in the season, and so the tropical storm season picked up a little bit later, and it picked up also in the Arctic as far as the ice sheet melting more later in the peak of global lightning strikes. So you had right around October 15th 2 standard deviation from the norm in the Arctic ice sheet melting, precisely and predictably because of space weather and atmospheric conditions from an electrical standpoint.